All right, Larry, we're live. It's great to see you again. Welcome, everybody. I'm here with Larry Maccherone. He's been a friend of mine for a while. I might have said his last name wrong, so happens from time to time. Apologize that for Larry.
That's because I say it differently. My family is split. Half of them say it one way, half of them say it the other way. So I answer to "Hey you." It all works. Maccherone is how I normally say it.
Maccherone, thank you so much. Larry and I worked together a couple companies in the past, and we've always had great conversations about all kinds of things with software delivery. And recently, I reached out to Larry to talk about DevSecOps and feedback loops, and we decided to do this webinar, and we're just going to have a conversation about how that plays in the value stream and maybe something about metrics too. In our last conversation, Larry, we were talking about the code that somebody likes today and pull versus push and so on. And it'd be really cool if you could comment on that with us here today.
Yeah. So I think let me give you a little bit about my background and sort of what I'm working on and have been working on. I guess you could say my whole adult career.
Mm-hmm.
I'm the director, I'm the head, I'm the lead distinguished engineer of DevSecOps transformation at Comcast right now. And the whole idea here is to get developers to change their behavior, to do something differently than they were doing before. And it's very hard to influence developers externally. So the security organization sort of struggles with this and has this sort of confrontational relationship naturally with the developer community inside of a large enterprise like Comcast. And I had learned, and this is related to what you said a minute ago here. I had learned that the Agile transformation movement was using some techniques that really hooked the brain of the developer. I mean, that was a very successful, movement, and you fundamentally changed the way software development is done today. And so I started to sort of become a student of developer psychology and development team sociology to figure out what's the best way to get them to change their behavior. And it is all about feedback loops. The Agile methodology is all about feedback loops. DevOps is all about feedback loops. But the key aspect of the feedback loop that you have to really do, and it's hard sometimes, is you have to give the feedback at the most relevant point in time. Right. And sooner is better, but not always. That's not a universal statement. And so let me give you an example for security scanning feedback. Developers write code in the morning. They submit a pull request that will kick off a pipeline, right? And the pipeline will run, some quality checks and some linting sort of style checks and some unit tests and some end-to-end integration tests and some security tests possibly. And those will then all report back as status checks on the pull request, and they'll either be amber if the test is still running, or they'll be green if they passed, and they'll be red if they failed. And you can set it such that the merge button for the pull request is grayed out or turns red and needs an admin override if any of those come back as red. And this is incredibly powerful because the developers are literally in love with the code they wrote this morning. It's like their new heartthrob, right? And they want their buddies on the team, their best friends, to say, "Wow, that's handsome," or "That's beautiful." And so they were looking for that endorphin rush in the afternoon when they get that notice that their pull request passed code review and got merged. And so when they see anything red on their pull request, they're like, "Oh, I better fix that, because if I don't, I'm not going to get the endorphin rush this afternoon of everyone sort of saying my new heartthrob is beautiful." And it really works. They'll do things they wouldn't otherwise do. And even if the problem is not directly in their code, if it's in the code related to the code they wrote, though, they'll fix up maybe even some long-standing things. And think about this as different than throw it over the wall security checks coming to a developer 3 weeks later. That's 3 weeks ago. I'm over that heartthrob. I'm onto a new heartthrob, the code I wrote this morning. Or what if it's something somebody else wrote 3 years ago? Now, unless cleaning that up helps them to get that endorphin rush themselves this afternoon, they're much less motivated for late feedback like that.
Makes sense to me. And that's what we were talking about, was the feedback loops coming at the scan at the end, and compared to getting them real time, and how you're talking about the endorphins and so on, and how that works out. And I've written some stuff on feedback loops through software delivery, and it's really interesting when you look at the tangible feedback loops and the intangible ones, I call them. They're the ones that give you a cue. And then there's the ones that you can automate, and some of them you can't automate. And when you're looking at software delivery, there's so much of that. And I often compare that to manufacturing, because in manufacturing, you don't have that same feedback loop through the development of a turbine blade or software, that you can get that real-time feedback that you're talking about in DevSecOps, and the metrics that you can get with it real-time as well. So it's really interesting when you talk about that, how they want to know right now. It just passed. Can I move this to production now? Can I take the risk of trying to branch this in or something, right?
Right. It is possible to give the feedback too early if it's distracting. So like a lot of developers say, well, I want the feedback in my IDE. And some of that is good, the red squiggly underline, right? You have a syntax error, right? You won't compile, you can't test it.
Right.
But if it's a security issue and you're given the red squiggly lines all the time, it can get distracting. And it's also, they're less motivated to pay attention to it if it's just sort of like oh, that's a secondary thing. That's just security stuff. I need to get it first to work. Then I can worry about the security stuff. But at the pull request is sort of the right place. That's still the same day, but it's not while you're typing kind of thing for security stuff. Now for syntax, obviously in the IDE is the better place for that. So it depends on the kind of feedback you're giving.
And when we were talking, you said you had kind of data to prove this, because I know you're about data. I've known you a little while. I know you like metrics and data. And I know that you have the data to prove some of this, even this feedback at the right time to the right level of training and all this other stuff. You have all these great pieces of data that are supporting what you're talking about.
Yeah, so I've got lots of studies that I've published over the years, and you're probably more familiar with my Agile metrics, sort of correlating Agile practices with outcomes like productivity, predictability, quality, responsiveness, those sorts of performance indicators. And I could talk about those, but more recently this year, as a matter of fact, in February, the last conference I was able to physically attend before this COVID lockdown mode that we all got into, was RSA, so the big security conference. Mm-hmm. And I published sort of an initial study. This year I'll be able to update it. Next year I'll be able to update it really, really tremendously. But the first year I studied it, when you take this approach of giving this feedback in the pull request, you have an 85% reduction in production risk from doing it this way. And so the normal way security teams give the feedback is they run the scans for the team, they triage them, and then they throw them back over the wall. Well, that's 1/6 as effective as doing the feedback right there. It's 6 times more effective to do it in the pull request than it is to do it after the fact. And even if you do it a day later, so we studied a day to a month later was sort of the range that we had. Right. And frequently the feedback comes from security people months later. So, yeah.
Or from something in production later, or.
Right, exactly. It's already been shipped. Yeah. So it's always that way.
And the feedback loops for those aren't real time enough either, right? So, and you're leaving risk out there, you don't get to those. So that's really kind of interesting, the numbers you've got out of that. And you're right, I do you mostly from when we were working at our past company together around Agile metrics and capturing that information, and how difficult it is to get that across disparate systems. Now I'll throw a ConnectALL plug in there. I think we've come a long way on that, and showed you some really cool stuff about those metrics. And what I'm finding is interesting is right now, and I worked in manufacturing, so I know these lean metrics really well, or the flow metrics or whatever. I'm really familiar with those. But I'm finding those metrics, even though we produce them, I'm finding that people want more, right? That's enough, but not enough. People want to know things like hierarchical representation. So imagine a world where audit and traceability, our reports are what I'm finding people want more of, as well as being able to look at the velocity of the team. And it's difficult to get a velocity across multiple teams unless you're rolling all that up into an infrastructure. But I think the lean metrics are great, but I think people want more. I don't know if you've touched on any of that recently or not. But
Yeah, so I have. I mean, so there was in fact, this was just published. When was it published? On October 11th. So it's not, it's not even, a quarter old. A write-up that basically takes a framework, a metrics framework that I had developed while, in our previous life together, and upgrades it a little bit. And the gentleman who wrote the article is building on publications I made, going back upwards of 5 years or so. Troy McGinnis is the person, and it's the 6 dimensions of performance. So you could probably Google it, or if I could screen share, I might be able to put it up here. Is that possible?
Yeah, I think so. There's a button.
Yeah, share screen. There's a share screen button. Yeah, is that okay? If I do that?
Yeah, just
yeah. So this is the balanced competing forces, balanced metrics framework, and everyone talks about do it fast, this lower left dimension here, and velocity, right? You talk about throughput in the lean Kanban world, but you also have to do it right, and that's quality. And you have to make sure you're building the right stuff. That's a fundamental message of the Agile framework. Do it predictably, consistently. When you give a forecast, then you should give a probability with that forecast, but you should hit it that probabilistic time. Quantity is important, and keep doing it. Resilience of the applications, not so much as the resilience of the team. So if you drive the team too fast and too much, then they will be unhappy, and then their performance will be bad later on. So do it fast, do it right, do the right stuff, do it predictably, do lots, and keep doing it are the 6 dimensions of the framework here. And Troy did an excellent job of writing them all up and sort of explaining what they all hear. So I'm going to paste this in the chat. If that, can everyone else see the chat, or is it just?
Yeah, let's see it. Yeah.
Okay.
That's actually pretty good, and when I think about one of the things I run into is we can measure quality a little bit. We can measure speed with velocity. We can measure, kind of measure predictability, which it's hard to measure, am I doing the right thing?
Oh yeah, that is really tough. And you can measure predictability because we found the best measure of predictability is the variation in the velocity. So if you can measure velocity, you can measure predictability in an abstract sort of way. It's not the same as say do. Did you commit to this date and did you hit that date? That's an even better predictability measure. But just that proxy measure of the variability in the thing. But yeah, did you do the right thing is really tough. So when I was at that previous engagement we spoke about together, I wasn't able to actually focus and do that works. But I've since done a 6-month stint at an organization who's focused completely on are you building the right thing? And so they basically will instrument your app as your users are using it and gather sort of the usage data. And I did a study there for those guys and published it. And the number one predictor for people renewing their licenses for that or converting from a trial license to a paid license, the number one predictor is the ratio of the short-term number of users, unique users on it, like per day, compared to the unique users per week. So if that ratio is close to 1, then your users are consistently going in every day. Now, not every app is meant to be used every day. So sometimes you have to do the week to month ratio, and sometimes you even have to do the month to year ratio, like budgeting kind of apps and that sort of thing. But the ratio of the short-term to long-term usage is the best predictor of are you building the right thing. And then, of course, you can measure the usage of individual features in your app with the same sort of ratio. How often does a user use this on a daily basis compared to how often the user uses it on a weekly basis. And that is a predictor of whether the features you're building are the ones that are delighting them and that are satisfying some need of theirs. But it is much tougher to measure. There's a lot more work to put that together.
That would be a trailing indicator of your success, though, too. It doesn't let you know up front. It lets you know that you've done the right thing, not that you've planned to do the right thing, right?
True, but this company really sort of focuses on that, giving you an early indicator. So the way they, if you have a new feature and you want to measure its effectiveness, they will allow you to sort of put a little sensor on there that the third time someone comes and uses this feature, I'm going to prompt them with a net promoter score for that feature. And so you can get pretty rapid feedback, like within a week or two of you releasing it. But you're right. But the cumulative metrics aspect of it can be really down the road. Quality is another one that's really tough to measure in real time and get early. And even like cycle time, you have to sort of specify a time period for that metric. So WIP is a sort of leading indicator of cycle time. So you measure WIP, and that'll then tell you what your cycle time is likely to be a month from now. You know, if you WIP today. So
well, cycle time's an interesting one too. I mean, cycle time in manufacturing is pretty straightforward, right? It's always the same size. It's the same material. You design your flow on the shop floor. With software delivery, it's everything they want you to do is a different size and a different set of skills and people as it comes in, and you have to really play on averages there than just one thing, right? So you measure just one requirement, that's not your cycle time. That's your cycle time for that requirement, not the team or getting stuff done. It's a difficult one to really get to.
Yeah, in the manufacturing world, this comes from the Crosby and Juran and Deming work, the statistical process control, the control chart feedback for cycle time, et cetera. You put the two lines around the curve, and I don't recommend you do that for software. I recommend that you use the cycle time chart to look for outliers. And the goal there then is to actually try to identify opportunities for improvement, right? So if you can look at a cycle time chart and see, well, this one is so much, these three are so much longer on average than the average one. Right. What happened there? Were they just bigger? Did we bite off more than we could chew? What's wrong there? I mean, and I showed you this chart the other day, when we were on with your coworker there. I forget his name. Yeah, there you go.
Andrew,
yeah, and I could share this again if you want. Okay, cool. Let me share screen again. It's going to do that infinite loop thing, unfortunately, when I do it this way. But
you showed me that. We were on with CJ Henry, the guy who's doing our metric stuff. And
CJ, that's right. That's right. Yeah.
He's doing a great job.
Yeah. So he asked me for a copy of this. I don't know if he's going to implement it in ConnectALL or not, but he asked me for the details on it. So I think he might be noodling on doing that. So, but yeah, so here's the idea. So this is the time on the x-axis here, and then the y-axis is how many days it took to complete. And the green things happen to be stories, and the red things happen to be defects. And these three up at the top here are sort of way outliers compared to the rest of these. They're in the 95th percentile and above. And so if you, this is sort of what you call a fat tail distribution, this sideways distribution here. And fat tail phenomenon are sort of like the most interesting phenomenon. The most useful to teach people with is the fat tail phenomenon, and so studying what's going on with these three bullets here, these 3 points here, is incredibly insightful. So when we did this with coaching, we coached development organizations to use this technique. We then started to gather the data as to what they decided was the reason that the cycle time would blow up for certain things. And there's really two things that sort of stood out and were dominant. Like they accounted for like 80% of all the the outliers in cycle time. One is cross-team dependencies. And so these three stories might all have cross-team dependencies. But the other one is data model changes. We tremendously underestimate how expensive and difficult it is to do data model changes. So we even did some natural language analysis on this. And so we could see data model or see schema or see the word, whatever, in the ticket. And so we were able to sort of do a word analysis to figure out what the reason for these outliers were. And the two that popped up were cross-team dependencies and data model changes. But it could be different for your organization. So looking at this chart and then studying the outliers is really incredibly valuable.
So like the green ones, those are probably tasks that were assigned to me. That's why they took so long.
Yeah, that could be the problem, right? We did do bad apple versus Rockstar analysis too. Yeah. There's some interesting stories there. The interesting thing about bad apple and Rockstar analysis is that when a Rockstar moves from a high-performing team to a lower-performing team, the performance of that team they moved to goes up, and the performance of the team they left goes down tremendously. I mean, you can see the movement effects. So there are individuals that can just bring the whole team up. And we know this in sports happens, right? So it's not surprising this also happens in software. But the bad apple phenomenon is just as true. You can take a poor performing team and move the bad apple to a high performing team, and that team's performance will go down. And so well, we were not allowed to publish the bad apple analysis.
So that's true of golf, too, right? So if I play golf with somebody good, I'll play better. If I play golf bad, I'll still play bad. So anyway, I'd let everybody know that, if you want to put in questions, we'll move into, taking on some questions right now. It might take a few seconds for us to get them, but do you see the questions there, Larry?
Yes, I just switched over to that chat tab.
So there's one about time to improve feedback loops. Is there a way to improve the time of feedback? Yeah, absolutely. There's a couple different ways. Now, I don't want to turn that into a ConnectALL pitch, but I'll let Larry kind of answer the question from his perspective on how to improve feedback time.
Well, I guess it depends on why the feedback is delayed. If it's just naturally a trailing indicator, meaning you can't calculate it unless you aggregate it for 90 days or something, then the technique you use to sort of get earlier feedback is you look for proxies that correlate with that earlier in time. So in the case of cycle time or time in process, you look at WIP because something that when you have a high WIP, that's gonna affect your cycle time a month from now. So high WIP today will affect your cycle time a month from now. And you can't always find those proxies, but often you can. If the reason that your feedback loops are taking so long is because you have a lot of manual steps or you have disparate systems and someone needs to pull it into a spreadsheet to aggregate it and run the analysis, then that's a good ConnectALL message. Maybe I'll just throw it back over the wall to you here and let you handle the pitch there.
Yeah, well, ConnectALL, of course, we connect all the tools in your value stream and we can orchestrate and execute things. So, if you're getting feedback late in the stage, we have that set all the way back to the developer's backlog, and we can also execute the real-time scan. So if I submit my code and I put a task in, I'm done, it'll build it, scan it. We can do all that automation to make feedback loops happen. But feedback loops are really interesting. I can take care of the feedback loops, but there's other types of human feedback loops that you can look at, analyze, and determine why you need them, and try to remove those as well. So feedback loops are really interesting, and they're just not technology, they're people. ConnectALL can automate the technology and give the people what they need to move faster, but you've got to figure out how to really automate the people too. And I think the biggest thing in feedback loops that are slowest are waiting for approvals in systems for people to move forward. I ran into that as well. So anyway, we've got a couple more questions here. I'll let you
I'm going to take that second one from the top, actually. I guess we can check off the bottom one. And so now it's the second one from the top. Is there any one of the 6 dimensions of performance that you recommend as the most important to focus on when starting out? Well, so the whole purpose of that chart, and I could pull it up again if you want, maybe. It is, yeah, let me do that. Let me do that. Give me a second here. So, I didn't expect to screen share so much, but just the easiest way to answer the question is this. So, and it's handy, so I may as well do it. So, see how, you need balance. So the whole purpose of this discussion is that if you push too hard on any one thing, let's say do it fast and do lots, then it's gonna show up in a negative impact on another thing. So, if you push for productivity, then quality is going to go down, right? So that's a trade-off thing. So I recommend, and I used to say you needed 4 of these dimensions. You need to report on at least 4 of them. So you have enough of this people pulling in different, forces pulling in different directions so that you stay in balance. If you try to just pick one, you're sort of out of balance. But so I said that I wanted you to be in balance. But the reality is that there actually is one metric that is more powerful than all of the other metrics, and I didn't realize this until I did the study, and that is, and I mentioned it a couple of times already in this talk, that's a work in process, WIP. Mm-hmm. If you do one thing as a team, if there's one thing you focus on, one metric you drive behavior improvement with, I would say it has to be work in process. If you lower your WIP, you get, and then I published this, so you can find this publication that the impact of Agile quantified is sort of the name of the publication. I can post a link to a video of me presenting the research, but if you lower WIP, you expect to get better cycle time, right? So if you're working on fewer things simultaneously, then each one of those things is going to get through the system faster, right? So it's just, you're swarming on fewer things. They're going to start delivering value for you faster, which makes obvious, perfect sense, right? But here's the surprising thing in the study. The quality goes way up. When you focus on one thing at a time, your ability to concentrate, the task switching costs, the mental task switching costs causes you to produce much less vulnerabilities and much less quality issues in your code. And so it's got this surprising benefit, and the impact on quality was actually dramatically even more impactful than the impact on cycle time, which is not what the theory predicts. The theory predicts that lowering your WIP will have the direct impact mostly on cycle time. So.
Is it kind of, little law is kind of that way, but they don't focus as much on the quality aspect.
Right.
They focus on reducing work in order to get more done.
Right.
Having the right whip through it, but
that wording's not accurate when you're talking about Little's law. You
right.
Don't actually get more done. In fact, when you lower your WIP, you will actually get a little less done in a given long period of time.
Right.
Okay. But what here's what lowering your WIP does. It means that any one thing that you start working on gets through the system faster when you lower your WIP, which means it starts producing value for you sooner.
Right.
And so the advantage is in lowering your WIP is really in the cycle time metric, in the speed metric, in the diagram, responsiveness, I called it in my paper. Not necessarily in the throughput or velocity metric. And it is if you have really high WIP, then lowering your WIP will actually improve your velocity or throughput. But when you get to have like medium a high WIP, lowering it actually does lower your velocity a little bit, but it improves your cycle time tremendously. So, and improves your quality tremendously. So it more than makes up for that cost.
Interesting fact: Lewis Little's still alive in Boston.
Is he really?
Yeah.
Oh my goodness.
I found that out a couple of weeks ago or something. Maybe not now, but last I looked at this year.
How old is he now?
95.
Oh my goodness! Wow, so that's amazing.
Kind of a living legend up there that nobody knows about. Maybe
I don't know. Are Crosby, Duran, and Deming? Are any of those guys still alive? No, they're all gone. They're all gone.
So. Deming's really gone. He's been a while.
That's what I think
about value stream management. I think about flow metric, value stream mapping, and the whole industry that we're building around that. I learned it in the 90s working in manufacturing, right?
Yeah.
It's been around longer than me.
It's interesting, though. I mean, the concepts apply, but
they need to be.
They need to be adapted, right? Yeah. Some folks try to just sort of like a control chart. I think is an anti-pattern in software. You know, it's the right way to do cycle time, to manage cycle time in manufacturing. But I consider my tip chart, the one I just showed a few minutes ago, an improvement upon that same concept, but except adapted more for software development.
Yeah. Well, I think about one last question at the top. I'll let you take it on if you want.
With leaders' fascination to get more and more metrics, what's the best way to define metrics which are relevant to the current and next stage of transformation, and keep the idealist wish list out? Okay, so here's this is a very interesting topic. I have a whole framework and I have a whole workshop that I conduct called the ODIM workshop, ODIM. And so let me describe sort of the where that acronym comes from. So when you have better measurement, you get better insights. And when you have better insights, you make better decisions. And when you make better decisions, you get better outcomes. So that's the way measurement helps you. That's the path that measurement sort of follows. The problem is that if you just start at the metric, the ones that are easy to capture, you could actually drive the wrong behavior. So Carmelo Anthony, Melo, was a big NBA player. I don't know, is he still a big NBA player? But he was a top 10 points per game scorer for several years when I sort of was looking at the data. And it turns out, though, that when he's out sick or injured, his team actually had a better chance of winning the game. Mm-hmm. So you look at points per game. Melo's a famous character, highly paid NBA player, points per game, top 10 in the NBA several years in a row. Yet he actually detracts from the team's chances of winning the game. And so the outcome that the team wants is not for an individual to get high points per game. The outcome that the team wants is to win more games. So what was going on here is that points per game is really a function of two things. It's a function of how often the shot is taken and the percentage likelihood that it'll go in. And so the only reason Carmelo Anthony had really high points per game is that he was taking the shots more often. But he was literally stealing shots from teammates that had a better chance of sinking the ball in a given condition. And he needed to pass the ball more and in order to maximize the team. He's a ball hog. And so he got a lot of, he took every opportunity, even if it wasn't a great opportunity, and he had a low chance of winning. And so we drove the wrong behavior because points per game is an easy measure to measure. But the measurement that really helps is this idea of wins contributed. And so when you take that analysis, some professors at NCAA schools that use this to coach NCAA teams, one of the insights that they got was that they noticed that the band between sort of like the depth of the free throw line and the 3-point line is sort of a no man's land, right? If you're in that land, you shouldn't take a shot. You should either dish it inside or drive inside yourself, or dish it back out, or take a step back and get a 3-point shot out of it. And so teams that are coached to this metric, they basically track where on the court they take shots, and they analyze that. That's the feedback loop for that particular metric for those people. Teams that are coached with this feedback mechanism of their hotspot, where the shots are taken, where they took shots in the last game, end up going 2 rounds further in the NCAA tournament than teams that were not coached this way. And but the whole idea is you want to wins contributed, you don't want points per game for an individual to be maximized. And so you start with the outcome you want to have in mind. That's winning games. You move back to, that's the O in ODM. You move back to the decisions that people need to make. Well, I need to either make the decision to shoot the ball or pass the ball. Now, you can't say, stop the game, let me go look at a chart. No, you have to coach it. So it becomes sort of ingrained in their thinking. And then the insights you needed was that hotspot analysis, where on the court, that's the kind of thing. And then the metric, of course, is where on the court the recording of the where on the court they took the shot, which they didn't have that metric to begin with. So they had to add that metric. And so you want to do things in reverse order: outcomes to decisions to insights to metrics you need to drive all that. And that is the best way to do that. And this is the concept, but there's several folks in the Agile community in particular that have been trained to do this ODM workshop, and I still do them every once in a while. I know Troy does them as well. Troy McGinnis, the gentleman whose screenshot I was showing a minute ago. If you want me to come in and do, or somebody come in and do an ODM workshop with your executives, that's highly powerful because executives tend to listen to outside experts more than they listen to their own people sometimes.
Yeah, I'm a fan of goal question metric, and that's kind of closed. But
it is. And in fact, Vic Basili out of University of Maryland Fraunhofer Institute is the guy who invented goal question metric. And I worked with Vic for a while. And I asked him if I could use goal question metric instead of ODM. And he said, oh, no, only if you do this 23-point framework and you give, you license this ISO 15939 thing. And so it is based on the idea of goal question. Yeah. I have to acknowledge it. And it's in my slide. I say, thanks to Vic for goal question metric.
Well, Larry, I've got to wrap up. It's been really great. Somebody in the thing said he still plays for Portland.
Oh, he still plays for Portland. Is he still doing well? I mean, I'm not an NBA fan, so I don't know, but yeah.
But it's always great, as you can tell. Every time we talk, we have a great conversation about some really cool things. I really appreciate you getting on the webinar here and taking time out of your day to give us some, let's say, some Larry insights on metrics, which are always spot on when I listen to what you have to say. And I look forward to maybe doing a couple more with you. Thank you so much.
Look, thanks for having me, Lance. Good to talk to you.
Thanks, everybody.